configuration. This right. Electronic configuration is simply a process of distributing the electrons of an atom within the shells or orbits of that atom. Within the shells or orbits of that atom. The electronic configuration of an atom can tell us the following. One, the electronic configuration of an atom can tell us the following. One, the group the atom belongs to, the group the atom belongs to. Two, the period the atom belongs to. Three, can tell us the valency of the atom, Four, it can tell us the nature or physical state of the atom. So I said, once an electronic configuration is properly done, it could tell us the group in the periodic table where the atom will be found. It can tell us the period. It can tell us the valency of the atom or the charge. It can tell us the nature, whether the atom is a metal, a non-metal, or metalloid. Electronic configuration is done in two ways. One, using the KLMN shell, and two, using the SPDF orbitals. Note that the K shell is number one. That is the first shell and the closest shell to the nucleus of an atom. And it is the closest shell to the nucleus of an atom and can take maximum of 2 electrons. The L shell is the number 2 shell immediately after the K shell. It can take maximum of 8 electrons. The M shell is number 3 shell, and can take maximum of 18 electrons. While the N shell is the number 4 shell and can take maximum of 32 electrons. paragraph. There are different quantum numbers. There are different quantum numbers. Quantum, Q-U-A-N-T-U-M. Quantum numbers. So I said there are different quantum numbers. Number one, the principal quantum number given as n, the symbol, the spin quantum number, the azimuthal quantum number, and the magnetic quantum number. These quantum numbers are very important in writing of electronic configuration. Different chemists have propounded the principle for distributing electrons into orbitals. One of these chemists is Hubbard. So we have the Hubbard principle, which we'll look into later. So let's look at the KLMN. Okay. Note, the maximum number of electrons any shell can take. Now shell, not orbit. The maximum number of electrons any shell can take is determined from the formula using the principal quantum number. The formula is 2n raised to the power 2. 2n raised to the power 2. Where n is the number of position of the shell in the atom. The number of position of the shell in the atom. For example, the K shell is number 1. Please look up. Therefore, the maximum number of electrons it can take will be 2 bracket 1 square, which is 2. While the L shell is number 2, it is 2 bracket 2 square. 2 square is 4, 4 times 2 is 8. While the N shell is number 3, so 2 bracket 3 square. 3 square is 9 times 2, 18. While the N shell is number 4, that's 2 bracket 4 square. 4 square is 16 times 2, 32. However, for convenience sake, eight is usually written as the maximum number of electrons the L, M, and N shell can take. 8 is usually written or given as the maximum number of electrons the L, M, and N shells can take respectively. So let's quickly look at this. We are looking at the KLMN electronic configuration. KLMN electronic configuration. So what I will do is this. We have the atomic number. We have the K, L, M, and N. We have the group. We have the period. We have the valency. and we have the nature. So, please take notes. Note. Once the shell is completely filled, that is, once the shell, end of the shells, is completely filled, that is, contains the maximum electron it can normally take. That is, contains the maximum electrons it can normally take. That atom belongs to group 0. The atom is an inert atom. Examples include the neon, the helium, neon, argon, krypton, etc. When there are few electrons in a shell, the atom is a metal. The atom is a metal. But when there are more electrons in a shell, say in the atomos shell, sorry, please take note, when there are few electrons in the atomos shell, not the shell, atomos shell, the last shell, then the atom is a metal. But when there are more electrons in the atomos shell, the atom is a non-metal. In the case of metals, having few electrons in their atomos shell, the electrons in their atomos shell are regarded as their valence. The electrons in their atomos shell are regarded as their valence, with the addition of the plus sign. Hence, metals have +1, +2, and +3. But non-metals have more electrons, 5, 6, 7, 8, in their atomos shells. Meaning they require extra electrons. They require extra electrons. The number of electrons they require to be completely filled is their valence. The number of electrons they require to be completely filled is their valence. Look up. I told you, apart from the K shell, others, how many electrons? 8, is that not? Now, if an atom has 5 electrons in the atom shell, how many electrons does it need more? 3. So write -3. If an atom has 6, how many electrons does it need more? So -2. If it has 7 electrons in the atom shell, how many electrons? -1. If it has 8, how many electrons? 0. So that's why I said any atom that is completely filled, that has completely filled shell, atomos shell, is what? Belongs to what? Group 0. Because it requires no electron. So let's quickly look at this now. I will just pick atomic number 8, 9, 10, 11, 12, 13, 14, 15. Yes. So the first shell will take how many electrons? 2. Remaining how many? 6. Now, because it has 6, it belongs to group 6 and period 2. So let's write this down. Right. The number of electrons in the outermost shell of an atom is the group. Is a group of that atom. The number of electrons in the outermost shell of an atom is the group of that atom. While the number of shells the electrons of an atom occupied, while the number of shells the electrons of an atom occupied gives the period of the atom. Gives the period of the atom. Please look up. Look up. This is 2. How many remains? How many remains? Now what is? I said for the group is the number of electrons in the atom's shell. 6, group 6. The period, how many shells did it take? 2, K and L, so the period is 2. Now the valency, how many electrons does this one need? It needs 2 more, that's minus 2. And when it is negative, it is what? Non-negative. That's all. So this 2, 7 belongs to group 7 and occupy 2 shells. Then minus 1, non-negative. Then this 2, 8. It belongs to group what? 0. And period 1, 2. And valency 0. And it's non-metal or inert element. Well, let's put inert element, right? Inert. These 2, 8, that's 10, remaining what? 1. So the last electron is 1, so it belongs to group 1. It occupies 3 shells, so period 3. Now the last electron is plus 1, it's a metal. 2, 8, 12, 2. Group 2, 1, 2, 3. Period 3, valency plus 2. Metal. That is how electronic configuration is done for KLMN shell. We will now look at how it is done for SPDF orbit. So please write this.